Hi folks, in this video we're going to work through the 2012 Junior Cert Higher Level paper, section A that is. Starting off here with question 1, 4 written answers. As always we'll start with the easiest one, orthographic. Then, first one here is oblique. This one here, isometric. And finally, planometric. Moving on to our next question. On circulating context and tangency, the incomplete elevation of a lounge chair is shown. A 3D graphic is also shown. Complete the elevation by drawing the arc BC. So this arc here. The arc BC has a radius of 35 millimeters and is tangential to the arc AB. So it's tangential to AB, possibly at point B, I suppose. We'll find out soon. It says show the point of contact between the arcs, so maybe that's it, maybe it's not. And it goes down and hits point C, as I said, radius of 35. I'll do first off, I'll just set my compass to 35. Once the compass is set to 35, I know that first off the centre has to be 35 millimeters away from point C if that's where I want the curve to finish up. So the centre is going to be there someplace. I'm going to let this compass to the side. I have a second one here. What I'll do is, from the centre point of the original arc AB, I'll just draw a random line there, any random projection. And I'm going to add the radius of the second curve onto the first curve. So back in 35 exactly here. I'll add the 35 on. So I'm after adding 35 mil there from arrow to arrow. With the second compass I have, I'm going to swing in the new distance from the center point out to this part where I've added the two radii. I'll just swing that in. That's the path of all possible 35 millimeter circles or arcs that touch AB, and then I have the correct one is the one that also coincides with the 35 mil arc from C. That is the correct center point. To get the correct point of contact, you join the centers, any two round objects. So join center to center. So it's not exactly on point B, it's just a little bit away from it. Right there, POC. My other compass here is still set to 35 millimeters, touching the pink point and finishing at point C. Third question here. Perspective again. Perspective is a staple question that comes up every year on the short questions paper. So we're looking at our vanishing point 1, vanishing point 2, and joining our projections to those vanishing points. All I can see at the moment, I'd like to maybe join the top of this roof surface here back to the vanishing point. I can't do a lot more up there at the moment. I'll get back to that in a minute. I just try and work out a little bit here. So I don't have an end to this front block. But what I do know is that if I can vanish from that and shoot through, because I know it's all one level surface right out along until I reach the front here. If I can shoot through that onto the front, it gets me one portion, but if I shoot through the external point here, that's going to be very useful. That'll actually get me the front corner of the object. So take it from the vanishing point and take it through and out. I'll use my sliding set squares to set up vertical. Taking a vertical off maybe one of the primary edges. And now I have the front corner of this, whatever it is, a bouncing castle. Heavy into detail. And one little part here that has come up in the past is getting the ridge point of the roof back in this other location. So what we need to be looking at there is the transfer of a height usually, and in this case it's the exact same. So I'm going to take, they gave a little guideline here which was a nice little hint. I'm going to project that back onto the back of the building. That's the base point of this little height line here. I'm then going to set up vertical again with my sliding set squares, and I'm going to emulate that line in the front which reaches the ridge off the pink point. I'm going to show where that is at the back. So when I create the same geometry front and back, it gets me my point. So off of the top of this opening here at the front, and I project back with the pink to the top of the opening at the back, up with the green vertical, same as here. And I can now just join the dots. No hidden detail, of course, so it's just a case of joining the dots, and there we go. Always looking for doorways or so, and so on. This internal edge is just what we're always kind of searching for, but in this case it's already shown. First 3 questions done. Moving along here to number 4, freehand sketching. Now this is definitely not an easy one. A workbench, the elevation and end elevation of a workbench are shown. Make a freehand sketch of the workbench, colour or shade sketch. I'm going to start on the ground as I always do with these, and to figure out first I'm going to go along here and the narrow way here. So along it's 1, 2, 3, 4, 5, 6, 7, 8 boxes long, and I'll start down low. 1, 2, 3, 4, 5, 6, 7, 8, and then in depth it's 1, 2, 3, 4, 5, 6, 2, 4, 6. I'm going to map out the full footprint of this object and just check the sizings again just for a second to make sure it's 2, 6, 8 long. 6, 2, 4, 6. The legs are in the corners. And the height is 1, 2, 3, 4. Although the legs taper in, I'm going to just create it out full size, vertical. And at least that way I can easily step off with the tapers, and I can count how many boxes in the tapers go in each direction, and I know that then I'll be able to map out the exact top positions. So looking at this, the legs are going to be in line here. So yes, along the 8 boxes the legs are at the extreme left and extreme right. So the leg is here and here. It doesn't step in. But in the other direction, then in the narrow side, it steps in by 1 box. So it's here. Is one leg. And I'm keeping this light because a lot of this is going to be overshadowed by the top of the bench. I'm guessing that whole back leg there will be hidden by the top of the bench. From the original front corner, I can go 2 boxes thick. So from the original front corner here, it's up 2, the original back corner, up 2, and here at the right side. There's a full solid front in this object, and then it's like 2 deep and 2 deep at the back, and a tool well in the middle, 2 deep, 1, or 2 wide, 1 deep. Full solid front on the bench here. too deep at the front and too deep at the back for the work surfaces. And the tool well is there. Now I can go back and heavy in the portion of the legs that is visible. The legs are joined, so up one, legs are joined just through here. And it's going to be slightly visible just there. Again, back leg cannot be seen, but a little portion of this guy can. There's the sketch of the bench now. Make a freehand pictorial sketch and then colour or shade. So it's up to yourself here. Because it's wood there, I might just show a little bit of the in grain of the wood. I'm going to take a light direction from about this side here. So there'll be a little bit of shading on that face. The internal faces here will be quite dark. Just hatch off them faces maybe. And a little bit of shadow on the ground. This back leg actually will have a little portion showing there, but that's about all I'm going to do with that. Maybe just heavy in along the base of the legs just to give it that little bit of depth and ground it. No, I think there's enough done there. Next up, figure shows the elevation and elevation of the sports net. A 3D graphic of the net is shown. Draw a development of the sports net. Don't have a lot of space here. There's definitely not enough space to do a full separate development anywhere, so I'm guessing that they'll want us to work over what we have here. As we're looking at the front, we're seeing the true shape of that surface, so we can just leave that surface and basically hinge everything around that. There is no base in this, so there's nothing to go down here. We're going to need the left side, the right side, the slope and the top. So these graphics are really handy to see. That's the left, the right, the slope surface, which of course is not shown right there as a true length, and then the top onto that as well. A little bit of sliding set squares to get going. I'll just draw some extra projections up and also across. I should have also drawn the XY line, extended that through. Start off with the left and right sides, each one being the same depth. On the bottom and on the top. And I've just realised my own mistake here. The mistake is that I should have made them go the opposite way, of course. If I'm doing this, I'm going to have to go the opposite way with that. My apologies for that mistake. The mistake here is that I'll have to apply that from the opposite side. They're not hinged around the tall point. So used to doing these drawings that way, but they are, of course, hinging off of this back short edge. So that should mean that the long portion is up. I'll come out the short portion and I'll drop down. That'll allow the slope surface, of course, to hinge around. So, good thing I spotted it in time. I'm going to take my vertical again and put this as the left side net, go all the way up, and right side net all the way up. Taking the size of the top area here and marking it out. Or back towards that object, back towards the main object, I suppose. There we go. Trying those guys back down at an angle. I can't unfortunately put in the fold lines down here now because they're already in heavy, but I'm going to keep fold lines in mind as I go ahead with this drawing. There we are. The slope surface. So I've done the left side down there, right side is done. This slope surface now is what I'd like to focus on next. First off, the true length of that slope surface is not shown here in the elevation, but it is shown here in the end elevation, which should also be the same as these slope surfaces I have here. What I can do is just simply rotate them around. They are seam edges. You have to match up with the part it's going to be folded against and glued. Let's just say glued to or taped to. I'm going to utilise my long double short here, standard marking for fold lines. Finally, this little top surface, which I'll take from the end elevation here and that on. No seam line or no fold lines here because it's just a solid line to finish. If you did want to, you don't have to, but you could shade that surface in, which just shows that it's all the one surface all the way up, and we can ignore their printed line. You wouldn't have to do that, by the way. I'll just do it for the video so that you're clear at home that that line that was printed through the object has no bearing on the final shape. Next up, question 6 here. A 3D graphic shows a reflective road safety sign with panels of equal width. Complete the elevation of the sign, showing clearly how to determine the width of the panels. What we're going to do here, we'll just take a look at the graphic. So each panel is equal width. So we'll just look at how many widths. There's one portion, 2, 3, 4, 5 and 6. So 6 equal spaces along. Let's just go with the top of this sign for now. So we'll take our random line, random angle, and we'll use the compass to mark off 6 equal spaces along that line. And what we'll do now is from the 6th space, we'll join it back to the end of the line. 6th to the end of the line and parallel back along. Once we have all points at the top, we then join the first point down to the corner and go parallel with all others. This can be done in continuous heavy detail here, so switch over to your H pencil if you like and finish off this drawing. So the first division up top joins down to the corner and all others are parallel. That's that drawing finished, so that's 6 out of 15 done. Number 7. Similar to some questions that would have come up before. There's a plane VTH and it cuts a pyramid. And we need to project down and find what the plan looks like. A bit of labelling always helps here. So point 0 there, the apex, it goes down to edge number 1, down to number 2, which is hidden in the elevation. Number 3 here on the right hand side, and number 4 at the front. What we're dealing with then is a selection of lines being cut. So in essence we can bring it down to the line 0, 1 is cut at this point, so it's a point on the line. And when we've it simplified down to that, I'll take a vertical, set my sliding set squares up there vertically. I'll take the point where the line 0, 1 gets cut, and I'll drop that point onto the line 0, 1, and so on. And I'll do the same there for 0, 2, for 0, 3, which is out on the edge, and there's 0, 4 finally here at the front. I can join the dots where all 4 get cut. And finally I'd like to just heavy in the edges as far as the cut points. So they're the portions of this pyramid that still remain after the plane has cut off the top. For practice sake, I think it's great to add any little bit of colour when you're familiarising yourself with these style questions. That part there in green is the portion of this pyramid that gets cut off by the plane. Next up is some freehand sketching, and again when we're dealing with a round object we're going to start off with just a square base, and we're going to create it out from a cube. Crow's foot to start. And we'll just get our proportions fairly right, going an equal distance here on the right hand side and on the left. That looks fairly good. Height to width, it's approximately 2 times the width, 2 units long and 1 unit high. So right there. We'll add the upper portion on just in a few minutes. I'm just going to start now just by getting this base portion. Pick the points that it's going to hit and try and freehand them in. And even if a lot of this is going to be hidden away after and overshadowed by some of the objects, just draw the full base profile in. The next profile up top is smaller, and it's actually quite a bit smaller here. So I'll just step in parallel to the edges I had. And again, pick your points. I can join them on the extreme edges. It's not a bad start. Now I need a smaller cylinder in the center, so usually I'd be creating it all out again, but this time I'm not going to. I'm just going to go for it here. Offset from the first one. Stands up vertically. And height wise, it's approximately that. That would be approximately the correct height. That's just by eye. There's an internal cut going down through this, so that's going to show an extra edge here up top. Now I grab the pencil just heavy in edges that are actually visible on the object. Final step then is to colour or shade. I'm going to start off from the inside area because that's definitely going to have to be a little bit dark. If we pick I'm going to pick a light source that's kind of coming straight in from the front. So to show round objects, it's often nice to start heavy around the back of the object where there is no light and it's not getting much of a cast light, and start lightening as you come forward. So keep going over towards the back and then lighten a little bit gradually as you come forward. That's it on the left side, the same here on the right side. And it kind of suggests that the object is round. I'll just do this something similar here on the cylinder. Won't go quite as dark on the cylinder though. There we go, but that's about all I'll do there. I'm not just hatching the ground, just any little bit of that. And that's plenty shading to add in there. Number 9 here, CAD commands. And this time we have, to start is an offset where you take a similar profile and make it a little smaller or bigger. We have the mirror where we create a symmetrical side through a center line. We have extrude boss. And finally, I think that's a sketch of a circle, so I'll sketch a circle. That gets us up to number 9. Number 10, a rotation. I assume the figure shows the elevation of an entrance barrier. Also shows a 3D graphic of the barrier in the closed position. Rotate the barrier about point P to show the barrier in the open position as indicated by the broken line. That broken line looks a little bit short now to me, so I'm going to just extend that on out. First off, I might number my points, so I have point P, I have got, I'll just go 1, 2 and 3 on the triangle. That's point 4 where the linkage joins, point 5 at the end, and point 6 to finish. I'll just take every point, even though I'm not quite sure where they'll end up yet. Just take every point, and that includes 1, 4, 2, 5, 3 and 6. If you feel more comfortable taking these, taking less at a time, then please do so. Don't feel the need to take them all like I did. The points that land on the line again, so from the closed position to the open, point 4, 5 and 6 are going to land exactly on the line again. 4, 5 and 6 on the line. Which means I can heavy in a portion of this line from P to 4 and from 5 to 6. Next, there's loads of different ways you could do this one now. I'll do is that. I'll draw the central axis going through the object. I'm also going to set up vertical. And that axis. I can now take the height off of the main bar, the main line from P to 6, and I can get the height up to 2, use that height and just set it again, and it's going to be, technically it's not actually going to be a long curve, is it? I don't think it is. It would actually be up along from the point that I measured from. So if I took that point there, slight difference here now. There's loads of different ways to do this, plenty of right ways to do this. If I take that center point of the triangle and bring it up to there, that's where I should be setting my compass. So my compass set from that pink point up to number 2, gets me from that pink point up to number 2. The distance from 2 down to 3 can be taken on the compass, or 2 down to 1 of course being the same, and I can strike it from 2 down to 1, and from 2 down to, there's 3 is outer one here. If I'm accurate, then when I join the dots, it should go through 0.5 on the line, which is pretty close. It should go through 0.4 on the line, again fairly close there, and finally 1 and 3 join up. That's close enough. And that's 4, 5 and 6. There's our rotation into the open position. Next, number 11 here is an angles question. First little bit of theory there is that the angle subtended on the arc is, or at the centre, is always twice that at the external, based on the same points here. So when you have 2 points in a circle, you join them externally to a point and internally to the centre. It's the internal angle is twice the external angle, so 58 times 2 equals 116 degrees. Angle B here, this looks like a regular octagon, and in an octagon it's 360 divided by 8, which is 45 degrees. And similarly, if you join all of the points of the object in, you get 1, 2, 3, 4, 5, 6, 7, 8 areas inside to make a total revolution, which is also going to lead to you getting 45 degrees. Number 12. Figure 1 shows the triangle ABC inscribed in a semi-ellipse. Figure 2 shows the axis and focal point of the ellipse and a point P on the curve. Determine the length of the major and minor axis and draw the triangle ABC. I'm going to have to use the rule here of focal distance. So F1 to P, join back down to F2. Added together is the major axis. So I'm going to add them together graphically. I'll take the distance from the point down to the focus, and I'll add that on, and that gives me a combined total length of F1 to P to F2 all together there on that pink line. If that pink line is equal to the major axis, I'd like to get half of that, so that I can set my compass and draw the major auxiliary circle. That bisection right there gets me the centre of the pink line, which is half of the major. So I can set out to the left side pink line or out to the right side pink line. That is half my major. They've done a little bit of hard work for me here. They've given me the centre point of the ellipse, yes. So I can draw the major. Two methods now. We can go up to the curve, up to the major, into the centre and across, or we can use half the major. Usually from the top of the minor gives you the focal, and this time we'll go backwards from the focal, gives you the top of the minor. Test yourself, make sure you're accurate from the focal to the top of the minor, so you can go from either side. That point right there where the arcs hit the minor is going to be the exact point for the minor auxiliary circle. Next up, I'm going to take one set square in line with the base, or in line with the major axis. I'll just slide it off back a little and set up my 30-60 and start finding some projections here to work from. Next step is to find our projections of all the points on the curve by coming down from the major and across from the minor. So I'll set up vertical, and down from the major on all 4 projections. And I'll come across from the minor on all 4. Once I have that done, just mark my points. This ellipse goes from external to external along the major in the horizontal, and on the vertical here it's hitting the internal point or the minor. It's going to hit these key points along the way. Hits point P as well, of course. And it can be so much easier if you're dealing with a loose page to move the page and keep your hand in position. Don't forget that last marker too, by the way. Such an easy couple of marks to forget. It asks us to draw the triangle ABC. And the triangle has 3 edges. And that's that one finished. That's number 12 complete. On to the final page of this, and number 13 on the higher level, 2012, is a design of a model speedboat. The design is not complete here. Figure 2 shows a small graphic of the boat, including the windscreen. The windscreen is based on a right angle triangle. Complete figure 1 to show the windscreen. First little thing they gave me is a little pointer that from the base corner leads up to hit the top of the windscreen. To hit the top of a triangle, basically. I'm going to take vertical off the side of the sheet here and just project. That's the first little part. Next, please don't ever do anything like this where you just offer up your set square and guess what where the triangle is, because that still is quite a close guess, but it's a guess. I'm going to have to think back to the rules here on semicircles and triangles. I'm going to bisect the line first off. I bisect that line and project. Find the center point. I can then draw a semicircle. That semicircle will have every possible 90-degree triangle based on this baseline that we have right now. Now that's not very accurate. Let's move that compass a little bit. On that, or in that semicircle, every possible triangle that's based on point A here on the left, point B here on the right, is going to have a 90-degree top angle. Let's move that back up. So every possible triangle using AB as a baseline that touches that semicircle will have a 90-degree angle. So what I'll do is I'll join it up here to point C. And that construction is required to get yourself the marks on a question like this. Here we are, my pointer coming from the bottom up. I have my bisect, and I have my semicircle. That will give me full marks on that question. Second last. The figure shows the elevation and plan of an axe head. A 3D graphic of the axe is also shown. Project an auxiliary elevation of the axe on the line x1, y1 to show the true shape of surface S. Surface S being here, which means that this xy line is parallel. I will take the angle of the x1, y1 and I'll slide off so that I'm projecting perpendicular. I'll take all points and project. There's something extra in here now that I also need to do while I'm here, and that is the circle. That circle is going to just appear as two straight lines. But how do I get them? Well, as I'm viewing up this angle here, it's going to be on the extreme left of my vision, but I don't know where exactly to go from. So what I'll do is put a 90-degree line crossing the object. That gets me my right and left projection position. Next, I'm just going to link up the elevation and plan. Yeah, why not? Actually, I didn't, you know what, this, for the one time I actually did not need to in this case. But nevertheless, what I'll do next is I'll take the heights, because when you project from a plan, it is an elevation. All that changed as I moved around from my original position to my new, all that changed was me, my viewing position. The height of the object never changed along the movement of the spectator. So I'll take my, it's only two heights in this case here. Take the first height, I'll just set it on any line, and I'll take the second height and set it again on the same line. I don't know what lines I need them for yet, so what I always do is I'll take my x and y1 angle, which is the ground, and I'll mark them heights across. So instead of taking the compass and marking them through with the compass on every single projection line, I can just do that. So much easier than setting the compass for the small area and marking it on every line, and for the large area mark it on every line. So now, what will I do next? I'm going to take, first off, I'll take this front surface all along here, and that whole front surface is full height. And it starts on the left hand side here to the right hand side here. Just heavy that guy in first. From the left to, there's the right. I'll put the top on this. That then joins up to this point, which is part of S, which is low, there at the front. That gives me surface S. S will also have a back sloping edge, which joins up to this point, up high here. And that also has the same height, in top surface. Now what's missing? Just set up my sliding again, my projection angle. The back edge of this object is going to be hidden. And finally, the hole that goes through is going to be hidden detail. What we also notice here is that we need to differentiate between, like if this was a round hole or a square hole or something, this center line that goes through does that for me. So I'll project the center of the hole up, and we always go one long, one short, one long. And that's the way we represent a center line on an object. Final question. Final question for 2012 Junior Cert Higher Level Section A is a bar chart. Or sorry, it's not a bar chart, it's just a chart this time. It's always a chart, a pie chart or a graph of some sort. What are we looking at here? The sales of equipment for technical graphics were recorded during a 6 month period. Nicely getting the plug in there. The following were the sales. July was 300, which is done first. Now I'll always take note of my units here. Are the units going up in hundreds or 150s, or what are they? And if it's 300, it's probably 1, 2, 3, I'm guessing. So I'll just take note of my units there, because we don't know. It's not predictable what the units are going to be, and if they will be very easy and straightforward like this, or otherwise. August 500, so that's 400, 500. How big does this go? 900. Great month in September. 500, 600, 7, 8. It doesn't go any higher than 9, so I'm going to stop there. So July is 300, August 500, September is 900, October is 4, November is 3, and December is 6. All the tech graph equipment for Christmas presents. Join the dots, complete the chart to represent the information graphically. But as part of completing, you would actually have to join the dots. Sinead, that's the final question on the 2012 Junior Cert Higher Level Section A. Thanks very much for watching. Best of luck with your work.